So if you recall, what we had covered last time had been an overview of the Java Executor framework. I talked about some of the key interfaces. There are 4 key interfaces that are part of the Executor framework. There is the executor service, the scheduled executor service, and the completion service. Those are the 4 key interfaces. So what we're going to do now, and this won't take very long because it's a really simple interface, is we're going to talk about the Java Executor interface, which is by far the simplest of the 4 key interfaces in the Executor framework. So the Executor interface has a single method, which is why it's so simple, and it is used by programs to submit a task, or you can have multiple tasks if you call the method multiple times. You can submit tasks for execution. And the executor is a functional interface. As you can see, there's just one abstract method. And this interface helps decouple task submission, in other words, the act of submitting a task, from how the task will actually be run by whatever implementation of this interface happens to be used at the time you ask it to execute a task. So that's very, very, very simple. Each task that you submit has to implement the Runnable interface. Runnable is also a functional interface, just has a single method. Very simple interface. It's probably the simplest interface imaginable. You have a method that takes no parameters and doesn't return a value. So it just, runs something. What this does, what Runnable is it's essentially a command. And so you're saying to the system, execute this command or run this command, and run it in the whatever implementation you've configured the executor interface to provide or have implemented by. Now you may remember that the command is a command pattern. Well, there's a command pattern. Hopefully you learned a bit about that in CS 251. And basically what a command does is it encapsulates all the information necessary to perform an action or have an event be triggered to do an action at some point later in time. So typically it's either in a different context or a different point in time or whatever. You can also use runnables to implement something called the command processor pattern. So the command pattern is a gang of 4 pattern, and it really is described in the gang of 4 book largely in the context of, say, menus for user interface frameworks or something like that. But you can also implement something called the command processor pattern, which is a pattern that appeared in the POSA 1 book and the Pattern-Oriented Software Architecture Volume 1 book. And this is used to package a piece of application functionality as an object. You parameterize functionality as an object and make it usable in a different context. That different context is typically a different thread or a different process. And so that's when you configure the executor framework, or the executor interface is implemented using an executor that runs commands or tasks in another thread. That's really the command processor pattern. The semantics of runnables are one way, and all that means is you give it some computation to perform, but the interface does not have a method that returns a result. So it's a one-way call. There's not two-way. You don't get results back, unless you program it through some other means, like a separate queue that you would keep track of and manage. The most common way to do this, not the only way to do it, but by far the most common way to do this, is to have the tasks that are executed by the executor implementation run in a background thread. So usually what you'll have is you'll have a main thread that's doing whatever it's doing, and it will interface with the user, typically. And then in the background, you'll have a bunch of threads running around, and that's where the work gets done. And then there's some way to coordinate back and forth. We'll talk more about that type of coordination when we get into the Android part of the course, because Android has some cool concurrency frameworks, like the Hammer framework or the async task framework, that simplify coordination between background threads that are running runnables, or creating runnables, and foreground threads that are doing other things. So we'll talk about that later. Okay, so that's really all there is to the interface. A very, very, very simple, a ridiculously simple interface.